In this video, we are going to be discussing density, unit weight, and specific gravity of fluids. Now, all of these topics are thoroughly covered in a fluid mechanics or hydraulics course, but we need to remind ourselves of what these things mean in our soil mechanics course. So let's go ahead and get started. Let's first start with density. Density is defined as the ratio of mass to volume. Okay, so density value is typically given by the Greek letter rho, and it's mass divided by a volume. Okay, so in SI units, density has units of what? Well, you typically would see maybe grams per cubic centimeter or kilograms per cubic meter, etc. Okay, so you have some measure of mass divided by some measure of volume, and you have other options besides just this, but these are two commonly seen SI versions of density. Okay, now one of the most important properties you should remember from a hydraulics or fluids mechanics course is the density of water. So the density of water is rho water, and we often see this in two forms. One form is 1 gram per cubic centimeter, or we also can convert this and see it in a different form as 1,000 kilograms per cubic meter. Now, of course, you can convert and you can express density of water in other variations of SI units, but these are the two most commonly used values for density of water in SI units. So these values you must know. You need to make sure you have these memorized. Density of water, you either use 1 gram per cubic centimeter or 1,000 kilograms per cubic meter. And of course, density can vary slightly based on elevation and temperature, but for the most part, these are the accepted values that we use in hydraulics and fluid mechanics, and definitely in geotechnical engineering and soil mechanics. Now, let's look at density in terms of English units. So in English units, units of density are going to have units of what? Well, these are most commonly going to be slugs per cubic feet, okay? So that's the most common, or you could see maybe slugs per cubic inch, okay? But most often you see it in the form of slugs per cubic foot. Now, I say most often, but in reality, we rarely use the English units of density, but it does occasionally occur. So what about the density of water? So if you are going to use the density of water in English units, it's going to be the following. We'll say rho water equals, and it's about 1.94 slugs per cubic foot. Again, we often don't use density of water with English units in particular, but occasionally it comes up, and this is what we see of it. Now, let's talk about unit weight. What is unit weight? Let's change colors. Unit weight is defined as the ratio of weight to volume. Okay, so instead of mass per unit volume, we have weight per unit volume. Okay, so let's follow the same process we saw with density, but with unit weight, we use the Greek letter gamma. And again, It's a weight per unit volume. So what would the units be for unit weight? Well, again, you have force per volume. Okay, and remember weight, we'll put a note here, weight is a type of force. So instead of kilograms per cubic meter, you would have something like newtons or kilonewtons per unit meter. So let's look at SI units and write some of these down. SI units. So unit weight would have units, for example, of newtons per cubic meter, or possibly kilonewtons per cubic meter, etc. Now, this should not be confused with pascals. So we'll make a little note here, okay? This is not a pascal, okay? Remember, 1 pascal is a unit of stress, and that's equal to 1, what? Newton per meter squared. So notice that unit weight is fundamentally a different physical property than stress, okay? A pascal is a unit of stress, and it's force per unit area. This unit weight is force per unit volume. So make sure we don't make this confusion, okay? What is the unit weight of water in SI units? Well, unit weight of water in SI units is 9.81 kilonewton per meter cubed, or you could often see it as 9,810 newtons per meter cubed. You must know this. You must know the unit weight of water by this point in your engineering career. Now, what about English units? So for English units, we do use unit weight quite often. We use unit weight much more often in English units compared to using density in English units. So what would the units for unit weight be in English units? Well, here we would say pounds per cubic foot, or we sometimes say PCF, okay? We also could use kips per cubic foot, or KCF. Now, this is maybe what you're more familiar with in terms of English units for unit weight. Now, what's the unit weight of water in English units? Well, you most commonly have seen this as 62.4 PCF, or 62.4 pounds per cubic foot. Okay, now this is very common in English units. So in general, we see unit weight in both SI and English units, but for density, we often only see density in SI units. We don't very often see density in English units with the slugs per cubic foot, okay? But nevertheless, you need to be familiar with all of this, okay? Now let's lastly talk about specific gravity. What is specific gravity? Let's change colors one more time. And we're going to say specific gravity is the ratio of and we're still talking about liquids. Remember at the beginning of this video we said of liquids. Specific gravity is the ratio of a liquid's density or unit weight to that of water. Okay? So this is often called true specific gravity. Okay? So let's take a look at this. We typically call this G sub S, and we say it's the density of a liquid divided by the density of water. Or we could say it's the unit weight of a liquid divided by the unit weight of water. Now, again, I'm saying all of these are equal. Why is this all true? Well, recall that unit weight is density times acceleration due to gravity. All right, so if you remember, gamma, the same unit weight we've been talking about, is rho times g. Well, why is that? Why is that rho times g? Well, this is simply because, remember, density is mass over volume. And so if you say mass over volume is density, and then you say times g, right? Then what happens? Well, you get mg over volume. You get mg over volume, and mg is simply what? Weight over volume. So again, all of this should be a review for you from previous classes, but these are all properties and definitions we need to remember, okay? So because of this, because unit weight is just density times gravity, acceleration due to gravity, we can write specific gravity, true specific gravity, as the density of a liquid over the density of water, or the unit weight of a liquid over the unit weight of water. Now, don't accidentally mismatch these. Remember, density of water and gamma water, or unit weight of water, are different numerical values. So you have to either use this ratio, density over density, or this ratio, gamma over gamma, unit weight over unit weight. And that concludes this quick review video.